Oh, okay. This problem is sort of, okay. We haven't talked about this problem yet. This is the one that give you the confidence interval, so let me do that problem and not do that problem. They gave you a confidence interval, right? With 69,000, whatever. So I'm going to give us one with some nicer numbers for a minute. What if that's a confidence interval for the real mean? What must x bar have been? How do you construct a confidence interval? You start with x bar, and then what do you do to it? What's the formula say for a confidence interval? X bar plus or minus something, right? So you start with x bar, and you add something, and you subtract the exact same thing. So where is x bar in its confidence interval always? Right in the middle, of course, because I start at it, and I add and subtract the same thing. So in this case, what would x bar have to be? 6. You can sort of see it, but can't you just do 5 plus 7 divided by 2? That's how you find the middle of any two numbers. Do the same thing with the uglier numbers they give you. Now, what must the error be? Error. So again, what's the formula? Formula saves your ass. X bar plus or minus error, right? So what must the error be? It must be the amount that I added and subtracted, because that's what it does. So what is it? What did I add and subtract to 6? 1. Uh-oh. Right? What did I add to 6? 1. What did I subtract from 6? 1. So once you find the mean, which is just really finding the average of the two sides of the interval, just see how far that mean is away from either side. That must be the error, because that's the amount that I add and subtract to it. That is not even a stats idea. It's just a number idea. Right? Okay, maybe. Anything else from homework stuff or general stuff? Can you believe that the semester's freaking almost over? It's insane. You're all like, the semester's lasted forever. What are you talking about, Jeff? All right. All right. So let's remember what the hell we did last time. Last time I think we finished that percentage hypothesis test worksheet. So let's just remember what we did, because I'm going to make you guys test each other to see if you have mind reading capabilities. That's what we're going to do today. So we're going to get data from the results of this test we're going to do on each other. Yeah. You're my test subjects. Okay. So what we did last time, hypothesis for a percentage. All the steps stay the same. The ideas of the steps don't change, because there's an idea behind hypothesis testing. It's just 3 things kind of alter a little bit in our steps. First step changes because I got to use the letter P. Not mu. Of course, because I'm freaking talking about percentages, not means. So that's not, well, of course. Okay. Second step changes because I can't use this test anymore. We just talked about this. What test do I use? This thing is so annoying. N. No hat. And let me remind you guys. If the claim was, for example, P less than 0.4, right? Where would that go? The high. And then the ho would be greater than or equal to. I like it. So, what do we do in hypothesis tests? We assume that the number from the claim is the real thing. We assume that P is 0.4. So once we assume that, do we know what P is? Yeah, it's freaking 0.4. We do the same thing for means. Don't you do minus the mean from the claim? That's the assumed mean. We say, assuming that's right, Let's try to do something really unlikely. So a hypothesis test is proof by contradiction. Assuming you're right, assuming the middle really is there. Look what we just did. Therefore, you must be wrong. That's the idea behind it. Stay with me now. Let me try to tie this idea. All right, what is S? What is S? Of a sample. When is the only time I would use it? If I don't know the whole standard deviation, right? So S is an estimate for the population standard. So I would not use S if I knew sigma. Now, what's p hat? What's p hat? Proportion or percentage from a sample. I'm only going to use p hat if I don't know p. And in a hypothesis test, I assume that I know p. And people have trouble with this part of mathematics, but this is what we do in everyday life. Assuming you're right, look what the shit just happened. So therefore, you must be wrong. That's the heart of hypothesis test. Assuming it is 0.4, my sample is 0.2, and my z-score is crazy, so you're wrong. So we go into it, we assume you're right, and then we kind of try to see if there's a contradiction to that. That's what a hypothesis test is. So what I'm trying to tell you is, I only use p hat and q hat if I don't know p and q, but in a hypothesis test, I'm going to assume I know p and q. Whew, that was a lot. But I really wanted to make sense why here I do NP times NQ, because I know what the free P is. In this case, it'd be 0.4. I don't have to use P hat. That's an estimate. Okay. If you wanted to estimate the percentage of gross month students that vape, what would you do? Take a sample. You'd ask some people. Would you ask every single gross month student? Do you have that kind of time? If you do, I'd question your life. We don't have that kind of time. We'd ask some, we take a sample and get a percentage. That's our best guess for the real one. I'm not going to use that if I actually know the real one, right? Okay, maybe. That's a lot more than I should have said about that, but that's the test. I can't use that test because that's for means. I've got to use the one that works for percentages to tell if it's what. If I pass this test, that means that I'm working with if I pass this test, I'm working with a normal distribution. That's what lets me do anything. The third step stays the same. That's the rejection region. Alpha, you look it up. 1 tail, 2 tail, stays the same. The fourth step is going to change because I can't use this freaky thing anymore because that's all about means. Get out of here. I got to use this one. P hat minus P. My data minus the supposed amount divided by the spread. This is the one we developed last time and we used it twice. Right? The steps don't change. It's just that the steps that talked about means before, well, now I got to freaking talk about percentages. Of course I do. But the idea, what are you talking about? Use P because I'm talking about percentages. What allows me to do anything? Use the right test for normality. What's the z-score? Use the right z-score formula. I mean, that's very hopeful. But the 5 steps plus you don't change, right? The idea behind each step doesn't change. So here's what we're going to do. Oh, well, I don't know. Do I have any of those? Scheisse Meisse. Let's see. Yeah, I just said Scheisse Meisse. Does anybody need the proportion hypothesis test worksheet? It was the one about Chicago policemen and stats students. Anybody else? Everybody has that? So we went over both sides of this last time. And however you feel about hypothesis tests, you have to understand, you have to agree that, thank God, nothing really changes when I'm talking about percentages. Nothing really changes. The 5 steps are the same. I just have to talk about percentages. So what we're going to do today, like I said, I want you guys to help me collect data. you're going to pair up with one other person. How many? Do we have an even number of people? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 26, 28. Yes, okay. If we didn't, then I could get tested. But, so I want you to find, right now, one other person. And then kind of like make it obvious. Get together. Why is everybody staring at me? Find one other person and then sort of make it obvious you have found somebody. Anybody need somebody? Oh, sweet. Perfect. Everybody's got somebody? So nice. Okay. Has anybody ever seen the original Ghostbusters? Nobody's ever seen the original Ghostbusters. Please tell me somebody's seen the original Ghostbusters. At the very beginning of the movie, they're doing this test. And let me put these cards up here and explain how this is going to work. Hopefully, I did this with one class. I hope to God they gave me everything back. We'll find out. So, while this thing warms up, hey, there we go. There's everybody. Yay. What you're going to do is you're going to take turns. For reasons that will become clear once you're done. Let's use the right thing. You're going to do this 25 times. Now that sounds like, but what I mean is, you're going to sit, somebody's going to sit with their back towards the other person. The person that has their back towards the other person is going to guess the card that the other person is looking at. So do these look at all familiar? You've got bacon, you've got positivity, you've got geeks, you've got Charlie Brown face, and you got star. Right? The alternative Lucky Charms. You guys with me? So one person is going to have cards, and they're going to go through them. And the other person's got their back. So he's going to go to the next card, tap me on the shoulder, and I'm going to guess which card he's looking at. And you're going to think about it really hard so the other person can read your mind. I'm not saying I believe in this, and I'm not saying I don't. We're just going to do this to get some data. Does everybody sort of understand what's happening? So I'm going to give each group a set of 10 of these, because I cut these out by myself. I didn't want to do. You're going to go through them once, go through them again, and then go 5 more times, 5 more of these cards. You get 25 results. And you're going to see why that's true at the end. We have to do 25. Okay. Let me give you guys, so please, when I give you these packets, can you just take a second and make sure you have 2 of each shape? I don't know if I trust this other class too much. So give me my stuff back. Yeah, I'm talking about you guys. All right, let me see. I think that should be enough. Just unhook it and count them off. Make sure you got 2 of each shape. I got extras if you don't. It's a little sparse. Yeah. Anytime. What do you got? You what? Extra one, okay. Let me know if you have too many. You should have 2 of each shape. You guys, everybody with me? You should have 2 of each. All right, so put your hands here and get bacon thing. Okay. Why are they so irregularly shaped? Because I cut them out. All right, yes?
We didn't get all of it.
You didn't get any. God, I'm evil. So double check there, make sure you have 2 of each shape. Everybody has 2 of each shape? Yes. Okay, that's just to maintain P. Real quick, how many shapes are there?
5.
When somebody guesses, what's the chances they guess right?
2 out of 10.
1 out of 5, which is? What?
2 out of 10.
2 out of 10, 1 out of 5, which is 20%. Right? So we are making a claim that you will guess more than 20%. That would be evidence that you did better than just random guessing. Does everybody understand what I'm saying? Right now, you don't care about that. You're just going to collect data. You're going to take turns. Somebody's going to sit with their back. The other person's going to look at a card, tap your shoulder, and you're going to guess. Now, whoever's doing that, you have to tally how many they get right, and make sure you get 25 total results. You guys understand? So you could put like right, wrong, and put a mark under each. It's up to you how you want to do it. Just please make sure you get 25 results. Everybody understand? So you tap the shoulder. If they get it right, you can put a mark. And then you just keep going. Make sure you get 25 times. Let me know if you need help, if you have questions. Otherwise, go ahead and get started. Okay. I think most of you guys hear what's going on. One person gets all 5. And then you're going to switch. So if you're guessing, you want to turn your back so you can't see them. There we go. You're going to look at a card, tap the shoulder, and you're going to mark it right.
So like we're just supposed to
Yeah. Don't tell them. Just record it. Don't let the person know what's going on.